Hello there guys, and welcome back to another epic Inexorable maths video. In this video we're taking a look at some more A-level maths, and we're looking at simplifying algebraic fractions. Okay, so this is situations where we can simplify fractions by taking the numerator of the fraction and the denominator and trying to factorize those and cancel things out. That's going to be our method today, okay? And this will then lead on to some more topics in the future that are relevant, but this is almost prior knowledge that we need. So again, this is kind of a GCSE topic. So first of all, notes. So basically the method that we're going to use today to try and simplify our algebraic fractions is to try to use the method of factorizing, simplifying the numerator, simplifying the denominator if possible. Sometimes it's not always possible, but if it is, we're going to do that. And then from that point on, we're then going to try and cancel out different factors. Okay, so let's just dive into a question. Let's just get straight into this thing. So we're going to start off with one that's more or less straightforward, I would say. And we are just going to, if my pen works, we are going to dive. There it is. Okay, we're going to dive straight into this thing. So we want to simplify this fraction: 7x to the power of 4 minus 2x cubed plus 6x all divided by x. Okay, so you may be able to just look at this and know what to do, but if it's not clear, we will use factorizing. You don't have to use factorizing for this question because obviously every single term in the numerator and denominator, both are, all of them, all four sort of terms, the 7x to the 4, that's 1, the minus 2x cubed, the plus 6x, and the x, they're all multiples of x, which means that there is a common factor of x which can cancel out. But if you didn't know that, then what you would do is you would factorize it. So you'd look at the numerator of this fraction here, and you'd say, okay, what's the common factor? How do we factorize this thing? Remember, I do have a video on factorizing that you can go and check out if you wish to. Okay, well, let's take the x. There's an x in all of those terms. And so let's factorize. So it's 7x cubed, not to the power of 4 anymore, because these two terms will cancel out. Not cancel out, they will multiply out together to make the 7x to the power of 4. Minus 2x squared, not cubed, for the same reason, plus 6. Okay, so again, if you can't see that, all we've done is if you were to expand this whole big thing out, you would get back to the numerator of this fraction. So we know that these are true, and this is the case. And this is still being divided by x. We have not done anything to the denominator of this fraction, and we get this. And from this point on, I would be quite confident to say that it looks fairly clear that an x cancels out here and here, just like so. And we end up with 7x cubed minus 2x squared plus 6. Okay, this is the answer. So basically what we're saying is the original fraction that we began with, 7x to the 4 minus 2x cubed plus 6x divided by x, that is the same thing as 7x cubed minus 2x squared plus 6. They're the same. So let's move on to something slightly harder. Okay guys, so now we're going to look at another example here. We've got simplify x squared plus 7x plus 12 divided by x plus 3. Now you might be noticing immediately here, okay, we can't do the method that we just used. We can't just divide everything by x or x plus 3 or something like that, because that would be ugly and we can't do it. We also can't divide by any constants. We can't divide by the number 2 or 3 or 4 or 5 or any of those things. We can't do it. So, what's the method? How do we actually do this? Well, we're going to factorize. We're going to try and factorize x squared plus 7x plus 12. So let's just look at that. Let's just look at this numerator here for a second, okay? Then we'll come back to the fraction. And I do have some videos on factorizing expressions in the form x squared plus ax plus b, or ax squared plus bx plus c, or however you want. I've got some videos on that, and if I remember, I will put them in the description or as a little pop-up bar for you to see. That's going to probably cover up my face right now. So we're going to have a look at factorizing this thing. Okay, so one thing to know is if you're in an exam and it asks you, one of the questions is simplify this thing, x squared plus 7x plus 12 over x plus 3. The only way that this is going to work is if when you factorize x squared plus 7x plus 12, one of the factors is x plus 3, because otherwise nothing will cancel out. So you can kind of cheat a little bit And you can say, okay, right, maybe I'm not sure how this is going to factorize. You can bet your bottom that one of them is going to be x plus 3, okay? And you can test it and you can see. But from here, it's a bit easier because you go, okay, right, x plus 3. Remember, you're looking for two numbers that times to make 12 and add to make 7. Well, one of them is 3. Makes things a lot easier because there's only one other number that it can be. 3 plus what equals 7? 3 times what equals 12? Well, 4. So this is going to be the result. And of course, if you expand this out, you know it's definitely true. Now, you don't always need to use the question as a hint. You can just factorize x squared plus 7x plus 12. You don't need to know that one of them is x plus 3. But if you're really stuck, then that's quite a good piece of advice for you. So we actually know that the numerator of this fraction is the same thing as x plus 3 times x plus 4. So we can rewrite the whole thing, and we can say x squared plus 7x plus 12 all divided by x plus 3 is actually identical to, and we're going to use 3 dashes there for the identical because they're always equal, doesn't matter what the value of x is, they're always identical to x plus 3, x plus 4, because that is the numerator, we've just shown that, but it's still being divided by x plus 3. But look at the beauty of this now, guys. Now we have a situation where things will cancel out very, very nicely. And so we get x plus 3, goodbye, x plus 3, au revoir. And then we can say that's equal to just x plus 4, just like that. So actually, strangely, it doesn't look like it, but x squared plus 7x plus 12 divided by x plus 3 is actually the same thing as just x plus 4, which makes things very nice. So that's another example. Let's do one more question. Okay guys, so I'm going to come at you with a exam question. This exam question is 4 marks, okay? And this is the sort of thing that you could really get truly in an A-level maths exam, okay? So here's the question. 6x cubed plus 3x squared minus 84x divided by 6x squared minus 33x plus 42 is equal to ax times x plus b divided by x plus c. We want to find the values of a, b, and c. So it's telling us that they are equal. We want to find the values of them, okay? So how do we actually go about doing this? Well, for now, let's not really look at the right, okay? We know that that's the form that we want it to be in, but let's mostly focus on the left because we want to simplify the left. That's the whole point of this topic. We're simplifying algebraic fractions. That's the whole point. So let's just take a look at the whole mess on the left-hand side. See if we can simplify it. And then maybe the a, b, and c will reveal themselves. So let's try and factorize this as much as we can. Let's just do it straight up. So looking at the numerator, I'm noticing that we've got, and it may be covering up by that thing there, so that's gone. So 6x cubed, 3x squared, minus 84x. They are all multiples of x again. So we can factor out an x here. So we get x times 6x squared plus 3x minus 84, just like that, okay? So that's the same as the numerator, and that's still being divided because we haven't actually done anything to this by 6x squared minus 33x plus 42. Now, we can't do the same thing for the denominator. We can't. But look at what's happening right now. We've got ourselves we've got the x outside already. This x, and there's like, you can sort of see this x here as well, right at the top there. They're out there, so we know we're kind of on the right track already. Now what we can do is we can see if we can factorize maybe 6x squared plus 3x minus 84. And also we can see if we can factorize 6x squared minus 33x plus 42 and see what that gives us. And I actually don't know that off the top of my head, but luckily you have a calculator and you can do it on a calculator in your real exam. And that's what I'm going to do as well. Okay guys, so I just did this on a calculator. So if you're, I know I've just kind of cut forward and done all of that work. So definitely pause the video and try that for yourself if you want. I don't want to go too quickly there. So, pause it, take your time, go and make sure, verify that what I've written is definitely true and you agree with it. But this is what I've got for the factorized versions of the top and the bottom. Okay, this is the result that I've got. The way that you factorize these things on a calculator, if you're curious, is you can use the quadratic formula if you'd like to. You can find the roots of the equation. And then whenever you get the roots, let's say one of your roots is minus 4, the factorized version of that would then be x plus 4. And we will look at why that is in the next video or in one of the next videos. So don't be confused as to why that is, but it's basically kind of, you add the negative of the root sort of thing to the when you're factorizing this thing. So I will speak more to that later, so don't be too confused. But if you're not sure, if you don't believe that this is the factorized version, you can expand out the top and the bottom, and you can get back to where you started. I'm quite confident that this is the factorized version. So the beauty here now is that once again we have a situation where things will cancel out. We have a 2x minus 7 and a 2x minus 7. They're cancelling out. And that is then equal to x times x plus 4 divided by x minus 2, just like that. And actually, if we go back and have a look at what we wanted, so again, I'll do a box around this in red. This is the form we wanted the answer to be in. This is the form we've got. This is the actual answer. And we can look at this and we can go, yeah, that's looking good. That's right. That's correct. So I'll do it up here. Just obviously, normally I'd put it at the bottom. I'd put what I'm about to write at the bottom of all my working, but I'm going to do it right here so you can see both of these things together, both of those things in the red bracket, so you can see what I'm doing. But you can clearly see here that A has to be 1 because if we look at the actual result that we've got, it's 1x. So A must be 1. B is clearly going to be 4 because here we've got an x plus b and here we've got an x plus 4. So just by comparing them, B must be 4. And C must be, well, if we look here, we've got an x plus c. And if we look here, we've got an x minus 2. You might think, oh dear, it's not a problem though, because x minus 2 is the same thing as x plus minus 2. Because the plus just would cancel out. Because it's a positive and a negative, that makes a negative. So x minus 2 is x plus minus 2, same thing. So actually, C is just minus 2. Because it's x plus minus 2 there. And this is it. These are our answers. So this is the factorized version. And that's what you do. And that would give you 4 marks in an A-level maths exam. Brilliant stuff, guys. Okay, we'll continue this topic in the next video. Thank you guys so much for watching. I really highly appreciate it. If you enjoyed the video, like, subscribe, share, tell your friends and family all about it. And I'll see you in the next video. Cheers.